Welcome, everybody. For those people who are used to seeing the manufacturing live, please don't worry, you are in the right place. Your normal host has been replaced by somebody from England. In fact, I'm going to be your guest host. My name is David McBriar. I'll briefly introduce myself so you know who you're talking to or chatting to. I'm a partner sales manager expert for Europe, and I'm part of the growing 3D Experience Works manufacturing team working with Mike Buckley. My background is I'm a mechanical engineer. I'm a time-served mechanical engineer. I've been in engineering 45 years, of which 43 years of that has been involved with programming NC, CNC machine tools. In industry, I've worked for companies that produce textile machinery and bottle washers, for machine tools, and also for forklift trucks. And I've also, over the years, worked for a lot of the CAM software vendors, either as a reseller or as a direct employee of the CAM software vendors. And now I'm working for Dassault Systèmes and have been doing since September last year. And as I say, I'm working with the team that includes Mike Buckley, but I'm based in Europe. So you can see from the time here, it's different if you're in a different part of the world, but you're more than welcome to this latest version of Manufacturing Live. So in this version of Manufacturing Live, we're going to be talking to my colleague, NC Kishore, who is the Senior Manager for Fabrication Portfolio for DELMIA. So welcome, NC.
Thank you, David. Thank you. Thank you so much.
Great to see you.
You too.
In this episode, I just wanted to get a sense of how you got involved in engineering and then how you got involved with DELMIA, and give us a sense of where your passion for manufacturing comes from.
Yeah, great to be on the show here. It's the first experience for me here, so it's good to share some past history of where and how I've come to where I am today. So, if you go back, first of all, my dad is a mechanical engineer, and then he's run a machine tool factory back in India at that time. And I grew up, working around small equipment and, trying to fix some scooters at home or trying to clean some carburetors and so I kind of grew into a mechanical mindset. And then when I got into engineering, I did my mechanical engineering back in India for 4 years, and then a bachelor's degree. And then soon after that, I got into a manufacturing industry. We were making CNC grinding machines and grinding wheels, like the specialized like CBN cutters, like cubic boron nitride grinding wheels and things of that nature. So I got into applications, and I used to travel all over India. And at that point in time, now this was in 95-ish. Commercial flights, of course, the commercial flights, but we were always encouraged to travel by train, And I used to travel. I used to live in south of India, right? I'm from Bangalore, south of India. So the customers in the north of India were in New Delhi and places like that. So I had to travel by train in the previous company, right? Just imagine sitting in a train for 2.5 days. It takes 2.5 days to go from Bangalore to New Delhi. So that's so literally, once you get off the train, for the next day and a half, you won't be still. If you sit in a chair, you keep moving. It's one of the anecdotes. It's just funny, but it is one hell of an experience. So, like I said, I grew into this mechanical way of thinking, and so after that company, then I switched from a real manufacturing environment, right? So I grinding machines and grinding and honing. I used to be a hands-on oil on my hands kind of a guy, and I switched to Deneb robotics in '97. It was all, and I was when I got the job in Deneb, the first thing I wanted to really understand was what is simulation, right? What is simulation? What are we trying to do? The virtual environment. It took a couple of months for me to sink in that we are trying to, make the real world in a computer. So yeah, that's where my journey with Dassault started in 1997.
And that was in India.
It was in India, yeah. Again, when I joined Deneb, it was again for 1 year. I was actually stationed in Knutsford in UK for 6 months.
Okay.
And then I traveled all over the place. Then they invited me to come to the US, and I was on a project with General Motors for working on tool load and things of that nature. So that was at that point in time. CutSim, I think the name of the project was. I still remember. So that's how I started my journey into this from a mechanical environment into this virtual environment. A little confusing there, but kind of got interesting after that.
Yeah, it's different to my background. My background is no manufacturing in my family at all. I just like taking things to pieces. That's not necessarily being able to put them back together again, but I was very good at taking them apart, but always inquisitive and wanted to know how things worked. So before we go any further, if you could like and subscribe the channel, that would be appreciated. And also, if you have any comments or questions, you can leave them in the chat and we'll get to them as we see them. So once you started working for Deneb, NC, obviously you're working with software, and you've moved to the US. So obviously that environment's completely different. So you're traveling around working with what types of companies?
Yeah. So before I start getting into some of those experiences, I'm going to mix my personal experiences and also my work experiences too, right? I mean, So some people might be wondering, what the hell does NC stand for? This is traditionally one of the first questions that I've been to many customers over the past 26 years. They've always asked, what does NC stand for? And again, this was at Boeing. Had about 25 people in this workshop. Before I started getting into the details of the software and stuff, they said, hold on, why don't you write what NC stands for? And I started expanding what N stands for, which is the native place that my dad was born in back in India. It stands for Nagaragere, but I'm not sure anybody would care for that. And C is my dad's name, Chikaramaya, and Kishore is my first name. So when I started expanding the N and C, it's got a lot of letters. And customers say, okay, stop it right there. NC is good enough. Just let's get on with it. So yeah, so that's a funny thing, and coincidentally, I don't know. Since my young age, as I said, growing into this mechanical thought process, and my engineering thesis was on a CNC machine with my teammates back in engineering, right? And of course, it was an easy project to get into because my dad was the general manager of the factory of this massive Indian factory, right? And we did that. And at that time is when I was exposed to CNC punch tape. And to some point, it makes me feel how old I am right now, talking about punch tapes, right? And here we are with software. You click a button, it generates the G codes, and you put it onto the machine. But back then, with those punch tapes, I have to be honest, I never understood the amount of time. It never sunk in, like it takes for getting the holes punched, and if there's a wrong punch on the hole, you've got to scrap the tape. You've got to redo it all over again. And I remember bits and pieces of the thesis project that we did, and we were looking at these tapes and what does this really mean? 1 to 8 numbers, and these holes are punched, and this is where the light, it goes through this sensor. It was thinking of it now. I mean, it's so fascinating that people were so kind of at that point in time, right? They were so technical enough to understand, the sensor, the light going through. I mean, how it evolved. You really got to appreciate the technology that's evolved from punch tapes to where we are today. Feature-based manufacturing. Where are we? So one side is, you make you feel that you're old enough. You're old right now. You've grown through it. But the other positive part of that is you've experienced that. The new generation would never even know what a punch tape is.
No.
They would never even understand the difficulties of life at that point in time where we have been through and how we have progressed. Anyway, so yeah, so that was a part of it. And then when I started my career with Deneb Robotics, when I called to come to General Motors on a project, I was asked to come here for 3 months. And that was the first time in my life I had left India. I had left the country out. I've never been outside India at all till 97. And I knew what a visa was to travel, but I didn't know the details of what a single entry means, what a multiple entry means. I had no clue. They just got me a visa, pack your bags, just go. Just a bachelor's. So it was exciting because you're flying out of the country. And 16, 18 hours, actually it was 24 hours, 2 flights coming into Detroit. When I came to the immigration officer, the first thing he would ask me after this 24-hour long flight or travel, why are you here? That thing just threw me up. I did not expect that sort of a question at all. He's like, okay, you're here in the wrong place. Why are you here? I was like, I thought he was going to tell me, welcome to the US and things of that nature. But no, it's like, that's when I thought, oh my God, is this where I ended up? So anyway, so I got into the country, and so I was given this project to work on cutting tools and how to improve the cutting life of these inserts. So we had a ton of data that at that point in time, I think it was a company called Delphi. I'm sorry, Delphi. Yeah, it's closed. I mean, right now it's bankrupt, whatever. It was one of the major, tier 1 suppliers for General Motors.
Mm-hmm.
And that was the first time I got exposed to this very homegrown environment where they were trying to optimize the toolpath based on some feeds and speeds and some information. But in Deneb at that point in time, we were not into programming. We were not generating a toolpath. We had a software called VNC, Virtual Numerical Control, which it's in today's world, you know who CG Tech is, Vericut, right? The product. So it's similar to Vericut, but VNC. All we were doing is taking G codes from NX or CATIA or whichever Delcat, and we bring it in, and we used to simulate the code. That's it. And to do this virtual simulation, we had to code. We had to program it. So we had a programming language. So it was a lot of things. So we got a lot of information from Delphi and General Motors try to plug it into our simulation system and read those, feeds and speeds that are on the G code at that point in time, and automatically adjust, the toolpath, adjust the feeds and speeds to try to optimize it in a certain way. So that was the first project, and so I worked for 3 months, and then my visa was expired, because the first question the visa officer asked me was, "Why are you here?" And then he was not very happy that I was here, so he just gave me a stamp of, "Okay, you're going to be here for 3 months," although I was invited to be there for 6 months. So then I had to go back, and then after 6 months, they called me back again. So so that's where, in the process of doing all that, I used to travel back in India too, and also been to Germany and other places there to start educating people on what we have as the value that we want to bring. The VNC, the simulation softwares, and things of that nature. But again, those were some really learning days for me, because in the past I used to work on a CNC machine, the honing machines, grinding machines, and in the previous job, right? And I used to go to different companies there with, government or ordnance factories making weapons back in India, nuclear fuel complex and stuff like that. So supplying grinding wheels for grinding those nuclear pellets. It never, the simulation environment never, initially, I should be honest, I never had the understanding of what the true value of doing this in computer, because the real money is on the machine. When the part comes out of the machine, that's the true value. What are we doing in this computer, right? What are we trying to do? So, but it slowly started making sense. Like, yeah, it is saving a lot of valuable time for the machine if you do it virtually here, and you crash here, do whatever you want in the virtual world. It's just virtual. So I started appreciating that, and then the company, they, of course, at that point in time, I was an applications engineer in DELMIA, and they wanted us to learn pretty much whatever we have in our portfolio. So I used to do, work on we had robotics. Robotics is one of our flagship products. So spot welding, arc welding, and so we had a pretty strong portfolio at that time for robotics, because the conception of DELMIA was around robotics. The robotics was the first product we ever had. Then slowly we moved on to other ergonomics and stuff like that, process planning and things. But robotics was the first one. So then I had to learn robotics. We had a really good product called Quest. It was a factory event simulation tool, queuing event simulation tool. So we were able to, the whole factory flow that we call today in our 3D experience platform that we have was in the queuing event simulation tool back then in Quest, and that was one of the hottest products that sold, and people were never letting it go. I'll not be surprised if even somebody might be using it even today somewhere. But that product was very powerful, and you could customize it to however you want. The entire factory with humans, machines, AGVs, the whole factory comes live, and basically evaluate your product flow. So that's we had to learn that. Then we had ergonomics. We're modeling humans and using it in the workplace. So that was one thing. So it's kind of bits and pieces of all the products we had to go and demonstrate, and because we didn't have the luxury of having a dedicated person for, okay, this is your job, go to machining or go to robotics. No, we had to do all of it. And many companies even now, they still do it. I mean, you have to be a master of all, so that's sort of the thing. So it was good. I mean, it's good. I mean, knowledge is power, right? Knowledge is power, and people will respect you only if you have knowledge.
Yeah.
Not if you have real money. In the end, you have knowledge first. But yeah, it was kind of encouraging for me to go and learn stuff. And again, coming from India here to the US, it was every time I visit a customer, it was an eye opener for me because like, oh my God, this is fascinating. And especially to see how they're using our applications. I had worked on a project for NASA that was a while ago, and they had, I believe, even in YouTube, even now there the links that are available where they used our solution. Envision is what we had for simulating the robotic arm coming out of the shuttle and grabbing a particular a satellite. That simulation should be online somewhere. But that is something really, really very interesting to see how people really used our applications at that point in time. So then again, 99 or 2000 is, I think, is when Dassault bought over Deneb. They bought us. I still remember those days. And then they also purchased two more companies. One was from Germany, one from Montreal. SafeWork was for ergonomics, really, and then for process planning was Delta from Germany. So they got these three companies together and called it DELMIA. And by the way, DELMIA, all these actually have these are what do you say, acronyms, right? DELMIA, then CATIA, computer-aided three-dimensional interaction application is what CATIA stands for. And DELMIA is I shouldn't have put myself there, but DELMIA stands for Digital Lean Manufacturing Applications. Okay, so that's how these things came by, and yeah, it was and somehow, I don't know, somehow since my name was NC, and my background was in CNC, or my projects in the past in engineering, or and my fascination towards trying to be dirty with oil, and I love the coolant smell. Somehow got into being and kind of started showing a lot of interest in machining, as it's been all the time. So that's how I kind of started focusing more into fabrication. And now, of course, when I say fabrication, it's just not machining. You go to YDDM, you go to additive manufacturing, and of course, we also use robotics sometimes now as part of the tending CNC machines, all of the things. So all these other scenarios came by. Yeah.
That's interesting. You should mention that because we've got a few questions coming.
Oh, okay.
So we've got a question from Vivek Kisaka. Sorry if I pronounced it incorrectly. What do you think the role of machine learning and artificial intelligence will be in the mechanical field in the coming years? So where do you think AI is going to take us?
Interesting. That question is really good. Thanks for that, Vivek. And I attended. I was invited to attend one of the workshops at NIST, National Institute of Standards here in the U.S. in Washington D.C. Then this was in 2006-07 timeframe, I think, where all the software major vendors like Dassault and UG at that point in time, and then we also had machine vendors and college professors. It was a group of all these team people, and we were talking about smart machining at that time. The workshop for about a week long was for smart machining. And I went there like, okay, we have a simulation product, and what is the smart machining are we talking about? At that point, at the end of the workshop, we were talking about machines being so intelligent that they can diagnose the quality of the product themselves. Okay, the machine learning is, the thought process of having that and having that integrated with the CNC machines, and also there are so many intelligent systems now to predict what the machine is going to generate, even before it starts machining it, right? So these things are, the data is there, the data and the knowledge is there digitally, and how do we make use of that in the best possible way, is left to us humans, to so it is going to impact. It's the machines are going to be much more intelligent, as we see every time I go to IMTS in Chicago every 2 years. That's some fascinating new things that you recognize and realize. I've never been to the Hanover show in Germany, but IMTS is the one that I always go there, and you see things that you won't believe. Just 2 years after, things have changed so much, for the betterment of human life, I would say, in one way or the other, right? So I think the knowledge is there, the capability to capture knowledge is there, the capability to reuse that knowledge is there. We need to. I think it's going to impact it in a significant way as we progress. Yeah,
I agree. I think we're moving away from separate systems, and we're going to a single source of truth, be it a 3D CAD model.
Yeah.
And then we're going to be able to use that to generate everything downstream from it. So the manufacturing, the planning, all of that. And the artificial intelligence is just, it's getting mind-blowing. They're getting really, really good. I always find it fascinating, not just on the machine learning and the AI stuff, but the technologies behind manufacturing as well. They improve. I can remember the first time I saw an additive machine.
Yeah.
It wasn't just a 3D printer. It was it could do additive and subtractive on the same machine.
Yeah.
And I looked at it and I thought, wow.
Yeah.
It's just crazy. We're always improving. And again, all that technology is getting cheaper and cheaper and cheaper. I can remember machine tools costing £500,000. So
yeah.
All this stuff's getting cheaper and cheaper to produce. We also have a second comment, and it goes back to what you were talking about, punch tapes. This is from Eric Beattie. He said, my first NC programs were punch tapes on an old DEC teletype machine in college. I can remember using a DEC teletype. And in fact, I'm old enough to know that you used to program machine tools, NC machine tools, with punch cards, not with punch tape. So that's the first system I used.
Oh, yeah.
Was punch cards.
Cards, yeah, right.
And the punch tape was a step up from that. It was much easier. But yeah. Everything's improving. Things are getting easier and easier. I mean, the fact that you can generate a massive program and download it to the controller, you don't have to worry about memory limits and that sort of thing. It's just incredible. We're making technology leaps and bounds at the moment. So we've covered the comments and the questions that are coming. If anybody's got any further questions or comments, please enter them into the chat window, and we'll cover them when we come to them. So you've covered your early career and Deneb being bought by Dassault Systèmes, and that's how you got to work for Dassault. So and how you got involved with the manufacturing portfolio. So in Dassault, what types of roles have you performed?
Yeah. So initially, when I started off, it was an applications engineer. And then again, applications engineer is basically developing best practices and so on. I mean, it to the most part, I still kind of do those things, but at some point it also changed a little bit into R&D, and it also I'm just getting distracted with the call here. I thought I had put it in airplane mode, but the Wi-Fi somehow gets the call through. Yeah, I was working in R&D for some time, programming and stuff. Um, it's more um, there's the same line of business. We used to call it as competency center. So competency center or applications engineer. I also used to be a machining solutions manager, and then moved into portfolio. Now I'm right now in R&D portfolio management, but I still see myself kind of doing the things that I love to do, like going to customers and um, it, and seeing how they really use our applications. That's what, and what I should even say is that um, when I switched from my previous job, which was hardcore manufacturing, to virtual environment, I started questioning myself: is this the right move for me? Because I wanted to be dirty, with oil, but computers and stuff like that never gave me an opportunity back to get my hands on a machine for so to say. I was able to look at the machines, customers, for instance, at Boeing. This was one mind blowing thing, where there were close to about 1,100 operations in a process, and this was in the V5 days in CATIA machining, and this was actually for a 747 wing part. My mind wouldn't think the size of the file. It keeps scrolling down. It just keeps going. And the best part is the computer and the software was able to handle that. And Keith McKay, I still remember his name. I mean, the programmer there, when he showed this part that's being machined on this gigantic machine, um, with such a massive. I would love to be part of that and see how that comes to reality, but I was only supporting him from the background. That's it. So that's what I was missing. But now coming to working with you, Dave, Mike Buckley, and the team with SolidWorks, I'm starting to smell oil more or coolant more. You know what I mean? Which I've started to love a lot more, because that's what is in me. That was before, and it's coming back again. I'm trying to relive my life, so to say. So every time there's this customer that we want to support in SolidWorks, they are like, show me how this works on my machine, and that's what makes things interesting, because you have it here in your brains, but how do you transform it in the real machine? Does it do what you're thinking of? And there's so much, every detail that matters. It's extreme, and I've experienced this personally. Even I forgot to change the units, for instance, right? That screwed the tool, and this was not too long ago, and things of that nature. It's so important that we need to appreciate the details that we put into these things, and one of the first experiences again is, I don't know if I wanted to show you one part. Um, I don't know if you can see my case here, but I have a bunch of parts that are 3D printed with DELMIA additive. But we also have one part here that, I'll take that out here. So this part here, right? I don't know, it looks like some prismatic nice part, but if we can share that link that I shared earlier, I think Ian can put it up there. This is a part of a mechanical leg. Excuse me. 2 years ago, when at SolidWorks World, Mike Schlutz, he's a Paralympic champion who had lost his leg in an accident, in a bike accident. And he designed his mechanical leg with SolidWorks, and this is one of the ankle pieces that kind of, this is where his foot would go, like that, I would say. There's a link that's probably available. I think you can just go and scroll down. You'll see him holding the entire mechanical leg, and this is the part that we machined in DELMIA on the shop floor, and that was when Mike Buckley and myself, we came to Fanuc Robotics here, right behind my office here in Auburn Hills in Michigan. And we spent 3 days, and we took a Fanuc robo drill, a 5-axis machine, programmed this part, and then took it to the shop floor and machined it. So that is something, it makes me feel, something that we do here is touching a human life, right? And that is so important for us to always realize that it's not just about software and sitting and punching code and doing things here, but we are affecting somebody's life. And I think that is that's always that's what keeps me interesting. So if there's anything that 2 weeks ago I was at this die manufacturing company who makes packaging for medical equipment. It's just packaging equipment. It's a whole bunch of dies. So in one way or the other, we are impacting the medical industry. That's one of the biggest manufacturers of dies for this packaging of medical equipment. And a few weeks ago, again, we were at an ice cream manufacturing equipment manufacturing company, Taylor. So it was fascinating to see because we have ice creams and they dispense it. You go to Starbucks, Dairy Queen or any other ice cream shop here. But the amount of engineering that goes into that, you will appreciate that when you see what really happens there. So these are things that it's coming back to me in terms of getting the software to the real world and especially working with you and the team, especially on the SolidWorks world. It's keeping things going.
It's great to hear the passion.
Yeah, absolutely.
It's amazing once you start feeling the pain that the customer starts to feel. That's what you need to be involved. Basically, it always amazes me when I used to go out. When I was very young, I used to assume, rightly or wrongly, I used to assume that my way was the only way that you could do things. And you soon learn that there are many different ways to do things, and people do things for a specific reason. And you go to these places and you see massive parts being made at some places, and you go to another place. I can remember going to a company, and he gave me a jeweler's loop, the eyepiece.
Mm-hmm.
And then he got a little magnetic thing, and he put this thing on my hand. It was a tiny little dot, and he said, "Look at that." And it was a screw that he'd been machined on a tiny CNC lathe. And it just blew my mind. Just blew my mind. As people do lots and lots of really incredible stuff.
Yeah.
Manufacturing world, and anything we can do to make it easier for them, it's great. So from a manufacturing point of view, now that you're seeing all these different companies that are starting to use the DELMIA products with SolidWorks, do you see that as a trend for people to move towards?
Absolutely. So I'm seeing the amount of interest that is coming from the SolidWorks users on what we have to offer. And also with 5-axis and 3-axis, the customers are understanding the power of the platform, the power of having to design with SolidWorks, push it into the platform, and maintain the associativity. That's possible today. That just works. So you make a change in SolidWorks, it updates here, and you're in sync. And the toolpaths and the programs that we create with DELMIA, they're all associative. Of course, they're associated with the surfaces. So make a change in the surface and make a revision in SolidWorks. Here, the toolpaths just get updated to the new. So it's making it more easy, and we are investing a lot of energy in automation. Now, yes, anybody can program a given part. I mean, any software can program a part, right? how fast can you do it? How intelligently can you do it? And can you capture all that and reuse? I'm not going to be here for many more years, right? I mean, we all retire, we go on vacation, people, whatever happens, it's part of life. We need to be able to capture that information and share it so that people can reuse that.
Yeah.
So our platform enables that. It's just native to the way the platform works today. And also the fact that this whole thing is available on cloud makes it even more powerful, because you can be anywhere in the world. All you need to have is a computer and an internet connection, and you're on it. So you can contribute to the evolution of the process, talking about NC manufacturing here, from wherever you are. And you can collaborate. I mean, our platform, enables this concurrent engineering, collaborating through the cloud, the single source. That's the power of everything. So we all look at the same data. We don't do a file save as and put it into a file system and send it an email, and you make a change. Nobody knows what happens. The platform enables easy sharing and changes instantaneously, because it's the same data that everybody's looking at. So you're never out of sync. So I think customers are starting to realize this. And people were quite skeptical initially that, oh, it's on cloud. Where is my data? Who is going to be? How secure it is, and things of that nature, which is fair for anybody to ask. We always talk about, if you want to access your bank account, how do you do that today? You don't go to the bank anymore. You just log on, go to browser, and go to your bank account and access everything there. So all that is on cloud. You like it or not, this is where technology is, right? I mean, you're not private anymore. Everything is on the cloud. Somebody somewhere knows about it somewhere, right? But it's also secure. I mean, security is another key thing that Dassault takes extremely seriously, right? I mean, David, you know that. The ITAR and all those things, and we have multiple ways, depending on how your company operates, to address those security issues on cloud. So from large companies to small companies, I mean, we are able to do that. So cloud is So I think I like to come back to your question again. People are realizing the value of the platform and how we connect to SolidWorks, and how easily we are able to use data and update and make changes and go by doing things. Yeah.
It goes back to the single source of truth, doesn't it?
Correct.
Basically.
Right. Absolutely.
Don't have disparate systems doing individual elements of a process. Have one system doing the whole thing. It's much easier.
Right. And no more silos needed. I mean, you're connected, and you're in the same single system. You're just native. You don't have to learn multiple systems. You just have one interface. Everything is right there for you. So I think it makes life much more easier.
So, I mean, one of the other things in the portfolio is the robotics, isn't it? I mean,
yes.
I see more and more robots appearing in industry for loading, unloading, tending, welding, that type of thing, assembly, pick and place. Mm-hmm. And DELMIA has products that enable you to, on the platform, of course, that enable you to program these things. Do you see these more and more as you're traveling around?
It is, yes, absolutely. As robotics, as I mentioned earlier, it's one of the flagship products for DELMIA from a long time. So we have introduced new roles. When I say new, it's not new technology-wise. It's just being introduced to this market. That's it. It's been there for 30 years. So it's a well-seasoned solution. Proven solution. So we have now introduced this RBS role, which will enable you to program robots. We do make our own translators. So we have over 1,400 robots in our standard robot library. We have direct partnerships with these robot vendors, and every time there's an update or a new model comes in, we build them. We have a team that makes sure the robot library is updated, and we also have a corresponding translator for that robot. These different applications, whether it is deburring or grinding, whatever applications, like or people have used this for gluing on a car, or for trimming, for instance, laser trimming. All those things are possible, have been possible with this product. People have used it, proven it, and it's just now being introduced to the SolidWorks world. And I think we can say with great confidence that we have pretty much all the capabilities that we need to address those scenarios. Especially robotics, pick and place. Yeah, absolutely. Those things are all just given. It's just there. It's a very powerful package. And we can also have a combination of, like when you talk about machine tending, right? So you need to have a robot load parts into this. This scenario, actually, I saw this in live action at a company called MetalQuest. It's a SolidWorks customer in Nebraska, and that's one of the most automated factories that you'd ever see. It's just amazing. And that's where this machine just loads parts into the CNC machine, takes it out. It's all caged. There's no human beings there. It's just programmed by these intelligent people, and that's it. It's just running 24 hours. And that's a fascinating facility. Anybody ever visit Nebraska, please make sure to just call into MetalQuest and just go there. That's an amazing factory. Yeah.
It's amazing that you can get these things to 10 machines, and then you can run the machines 24 hours a day.
Absolutely. Yeah.
It makes sense, really, doesn't it? I mean, instead of having some chap in front of it loading and unloading, he can be doing something much more interesting than doing basically that type of work.
Totally. Absolutely. The amount of, it's just perpetual. So, it's just very amazing.
And on the machine tool side of things, obviously you've seen lots of machine tools at big companies and at small companies. Do you see a trend? Do you see them getting more complex? Do you see people moving towards mill-turn machines?
Yes, that's a good question. Yeah, mill-turns and especially Swiss turn machines too, right? So these are some really complex machines, and they're getting more intelligent, more capable as we progress. There's parallel axes. There's so many configurations that the machine vendors are coming out with, and we are able to support those kinds of machines in our DELMIA environment. There's complex mill turns. There's more EC keys or a parallel ram axis, for instance. That we have a EE ram tech from Mazak, which has a parallel Z axis that comes down. So it's a combination of milling, turning. Yes, we can support that. Swiss turns. You can imagine how complex Swiss turn machines are. So we are able to program that, and it's just there. And I think it's time, especially with SolidWorks and DELMIA both having a really strong connection right now. These are things that are possible. And as we go into the SolidWorks market, we are introducing other automation capabilities too, where feature recognition is already there, to be able to reduce the amount of time spent to program a given part. So we are enabling, with the process with templates. You can create your own template for a certain feature. You can put all the intelligence to that, and then capture that as one template. So it's a reusable template. So if you come across another part with a similar feature, you can just apply it and reuse it. You don't have to go and spend more time programming the feature again. So we are putting in a lot of effort into automation to help reduce the programming time for a given part, and also to a point where the DELMIA piece of software is also exposed to knowledgeware. And when you get into knowledgeware, that is mind blowing because you can control the type of surface finish that you want on the part with knowledgeware. So what it does when you apply a certain set of operations automatically through this template, you can look at the tolerance that is required for the surface and pick only those necessary operations with the right cutters to work on the surfaces. So all that is intelligence that is captured. So we have 3 or 4 different levels of automation. So it basically gives you, a platform for you to go and put your knowledge into that. And once it's there, it's just there to reuse and make things faster and make you more competitive because your brain can be more innovative, thinking of other things to do. So yeah, so I think, and we are also extending this integration from machining to additive as well, right? So when you print a part, when DELMIA's additive solutions, we can wire idiom it out. We have a program for doing that. We have an app for that. You can also take the entire setup and do a 5-axis machining from additive to machining. Again, what is making this possible is the platform. We are all on the same platform. The additive, the machining, all these other components, the robotics, everything. So it's all on a single platform. So we can share data. It's a single data that we can share between robotics, additive, and machining. So you can think of those things.
Yeah, exactly. We're getting towards the end of the hour. If anybody has any questions or comments, there's still a chance to ask those questions, comments in the chat window. From you said that the automation is getting multi-level and getting more integrated so that it offers you things dependent on the tool and the material and that type of things. Do you see that becoming even more automated in the future, or do you see that we're getting to the limits of the automation?
Yeah, the automation it's always a moving target. The more you automate, there are new ways that we can still further automate. I don't think we have ever come to an end of automation. No, we haven't come there yet. I mean, it's like there's always new ways to make things easier. So this is just going to be a moving target, and we'll be catching up to it for a number of years. I think, it's just that we are the capturing of the knowledge. There's no limit to that. In my view, there's no limit. Every time you think, what more can Apple do on an iPhone? There's a bunch of other new things that they come out with. And similarly with other car companies or other manufacturers, that they always have something. They always progress. And that's human life. That's it.
And that's the thing, it's progress, isn't it? And you need to keep making progress. Whether we'll get to the point where we can replace the programmer, the CNC programmer, maybe you can make his life a lot easier, but whether you can replace him or not, I don't know.
Yeah, no, I've always thought that. I mean, what if we automated to such an extent where we're not going to even support human beings, right? I mean, that's how they have to make money, families and all that. So I don't think the human factor will ever go away because somebody needs to make things happen. Somebody needs to program. Somebody needs to do. If the machine is completely automated, somebody needs to program that. So his capability is used somewhere else. up front. So that Metal Quest example I talked about, right, is running for 24 hours. The robot is tending, the parts are being supplied, machine. So somebody needs to program all that. There's a variation of the part. Somebody needs to reprogram that. Somebody needs to maintain the whole equipment. So instead of standing there and loading part up and back and forth, he's programming and thinking of other new things that he can do. So I think the human factor is always going to be there no matter what. It's just going to be used somewhere else. Yeah.
Yeah, the automation's freeing up the humans to do the more interesting things.
Absolutely. Yep.
Yeah.
So
rather than replacing us.
Yeah. So far, yeah. I wanted to just show you this cute little thing that I have here for a long number of years. One of the customers gave us this. It's actually a 5-axis machine. You see this? The table.
Oh, yes.
That is X.
Yeah.
And you see this thing is going in Y.
Right.
See this? And then this thing comes down like that.
Yeah.
That's Z. And then there is this tool that is already mounted. I don't know if you can see that. There's the drill right there. That's looks like that. There's a tool changer. This rotates. This tool changes here. This spins. I mean, I've always had this for about 20 years now. I think it's something very, very cute, very unique. It's 5-axis machine. Just want to share that. And here's another part that one of the first projects that I did. I'm surprised they actually sent it to me. This was from NASA. This was some part that was used on some. I don't know what. I didn't get all the details, but of course, it's with NASA. It's going to be on some satellite or something. But this is something that they machined. And they sent me this sample part just for me to have it. I've had it since '98. Wow. It's an interesting part.
It's amazing. You collect all these parts, don't you, NC? The little parts that you've been involved with manufacturing.
Yeah, it's just memories. It's just that now I can relate to what this was and who sent it. And some things to keep forever.
And the sense of satisfaction of programming it and then seeing it machined.
Yep. That's the thing. Yeah.
Exactly. So I'm not seeing any further questions. We'll give it a few more minutes just in case anybody wants to ask any questions. As I say, just enter them into the chat window. But we are getting towards the end of the hour. So yeah, thanks very much, NC, for the chat and the insight into your involvement and journey into manufacturing. It's been really interesting.
Thank you. Thanks, David. And I think it was pretty interesting and got me back into the memory lane of had to think about what happened. So it's a long way. Yeah.
As the years pass, it gets more difficult to recall these things.
Yeah. A lot of memories.
A lot of good memories. Now,
a lot of good memories. Yeah.
I've always been very fortunate in that I picked a career that I enjoyed doing, and you're the same.
That's very important. You do what you love to do, and that's it. That's what keeps you going. So
exactly.
Yeah.
Well, I'm not seeing any more questions, guys. So this is your last opportunity. If you've got any questions or comments, please enter them. We're nearly at the hour. But obviously, there's going to be another Manufacturing Live episode coming up. I don't know who the host is going to be for that, but please tune in if you can for the next episode. And like I say, thanks very much to NC again for participating in this episode and sharing his journey into manufacturing. And it's been interesting for me to do my first host of the Manufacturing Live stream. So, okay, I'm not seeing any more questions. So,
all right, thanks, David, and you've been an excellent host. Good questions. It was a good conversation. I think it was. It's all good. So, have a great evening. Yeah.
Okay, and I'll pass it over to Ian to close the session.